Hi, Hako. This is my bonus problem 2 solution. So in the question, we are given two masses connected by a length of string over a pulley, both on inclined planes. From the question, we are also given these conditions in the top right-hand corner. Mass 2 on the right-hand side is greater than mass 1. The string length is constant, and there is zero friction on the plane, so we can neglect any calculations including friction. Um, so part A tells us to express the string tension as a function of the masses and the angles. To begin with, I decided on focusing on each mass individually and calculating the force vectors applying to each one. So as you can see in my diagram here, I have mg, the force acting on the mass from gravity, and then along the plane we have the force pulling it down, which is the one component of the mass of the gravity force. And then up the plane we have the force tension of the rope. Similarly, on mass 2, we have the component mg, which can be split into your perpendicular and your parallel components, and the force of tension pulling it back up the incline. So looking at object 1, we have sum of the forces is equal to ma, which is Newton's second law, sorry. And if we look at the sum of the forces, so we look at all the forces in M1, because it's stuck on the plane, we know that in the y direction, if I state that my x direction is up the plane, my y direction is perpendicular to the plane. We have that in the y direction, it equals 0 because the mass is not moving up or into the plane, it's remaining on it. And so therefore we don't have any of the y components, we only have the x components, which we know is up the plane is force tension 1, which I've said is positive because initially mass 2 is greater than mass 1. So using a bit of intuition, I expect that the acceleration will be to the right. Hence, I said that the positive x direction is to the right. So we've got force tension 1, and then down the plane is the force pulling the mass down due to gravity is equal to ma. Solving both of these, so I can rewrite my force pull as the parallel component of the weight force, which is mg sine theta, equal to ma. And rearranging for a, I get this equation here. Similarly for object 2, I did the same thing. However, because the force pulling is in the positive x direction here, it's force pull minus the force of the tension, unlike in object 1 where it was force tension minus force pull. So I get two equations for acceleration, but that is just talking about them individually. If I look at the entire system, they are connected by the constant length of string, and whichever way it moves, both objects will move at the same acceleration. Hence, I can go through and say that the accelerations are equal because it is still one system. So boxes are connected as a single system, therefore the acceleration of each object will be equal. So if I set my acceleration 1 equal to my acceleration of number 2, I get this equation here. Force tension 1 minus m1 g sine alpha over m1 is equal to m2 g sine beta minus force tension 2 divided by mass 2. Now if I do a bit of algebra and I rearrange, I get down the bottom here, I want to get a force of the tension. And since this is a connected system, I know that the tension forces will be equal, opposite in directions, but they will be equal, because the tension on the string is going to be taut on both ends, so the forces will be the same. So solving through here, I end up with force tension is equal to m1 m2 g sine beta plus sine alpha over m1 plus m2. So that is an equation answering number A. So I got the tension force, sorry, in terms of the masses and the angles. Part B asked me to find conditions that the system is at rest or in uniform motion. So I know that through kinematics, that a system is at rest or in uniform motion when the acceleration is equal to 0. So there's no force accelerating it or slowing it down. So hence I can go through and set my two acceleration equations that I calculated before to 0 and then solving. So for force tension, for the object 1, sorry, I get force tension minus mg sine alpha is equal to 0. Force tension equals m1g sine alpha. Just adding it to the other side of the equation. And similarly on object 2. Because we know that force tension 1 is equal to force tension 2, as I've stated here, we can go through and we can let them equal to each other. And because we have a constant gravity on both sides, we can cancel that out and we end up with m1 sine alpha is equal to m2 sine beta. So when this equation is true, when they do equal each other, we know that the acceleration is 0 and hence it is either at rest or it's in uniform motion. We can't tell which one it is, but we do know that those two conditions are met. So just looking at this equation, I can go through and say that this statement is true under these conditions. So if, just intuitively, if m1 is equal to m2 and sine alpha is equal to sine beta, we know that, well, if two numbers times together is equal to the same two numbers times together, then they're equal to each other. If the ratio of m1 to m2 is equal to the ratio of sine b to sine alpha, we will have an equal ratio and those two will be equal. Thank you.